Welcome learners, and today's lesson is topic of salts. Subtopic is effect of it on salts. We're going to look at three types of salts, that is carbonates, nitrates, and sulfates. So we begin by carbonates. Now carbonates of aluminium and iron do not exist. Reason: they are hydrolyzed by water and air to form acidic solution. Carbonate of sodium and potassium do not decompose on heating. Carbonate of calcium, magnesium, zinc, lead, and copper decompose to give you metal oxide and carbon dioxide gas. Examples: A. Copper carbonate. Equation is copper carbonate solid arrow copper oxide solid plus carbon dioxide gas. The equation is balanced. Now, observation made when copper carbonate is heated during the experiment is green copper carbonate changes to black. After the experiment, a black solid is formed. Reason for the observation made: copper carbonate decomposes on heating to form copper dioxide, which is black, and carbon dioxide gas. B. Zinc carbonate. Equation is zinc carbonate solid arrow zinc oxide solid plus carbon dioxide gas. The equation is balanced. Now, observation made during the experiment is white zinc carbonate solid changes to yellow when hot and white on cooling. At the end of the experiment, there's no observation because zinc carbonate is white and zinc oxide is white on cold. Now, reason for the observation becomes zinc carbonates decompose on heating to form zinc oxide, which is yellow and hot, and white on cooling, and also carbon dioxide is formed. C. Lead carbonate. Equation is lead carbonate arrow lead oxide plus carbon dioxide gas. Now, observation made during the experiment is white lead carbonate solids changes to orange on hot and yellow on cooling. At the end of experiment, the observation made is yellow solid is formed. Reason for the observation made is lead carbonates decompose on heating to form lead oxide, which is orange on hot and yellow on cooling, and carbon dioxide gas. Now, next we look at these hydrogen carbonates. Now, hydrogen carbonates, we only have four in existence. We have sodium hydrogen carbonate and potassium hydrogen carbonate, which exists in solid form. Then we have calcium hydrogen carbonate and magnesium hydrogen carbonate, which exists in solution form. Now, when hydrogen carbonate is heated, it decomposes to form metal carbonates, carbon dioxide, and water. An example of a reaction here is effect of heat on sodium hydrogen carbonates. Equation becomes sodium hydrogen carbonates arrow sodium carbonate solid plus CO2 gas plus water liquid. To balance the equation, put 2 where we have sodium hydrogen carbonate. Now, on further heating, we have said sodium carbonate does not decompose on heating. Now, example number 2 is effect of heat on calcium hydrogen carbonate. The equation becomes calcium hydrogen carbonate arrow calcium carbonate solid plus CO2 gas plus water liquid. Now, on further heating, calcium carbonate, as we mentioned earlier, decomposes to form calcium oxide plus carbon dioxide gas. Now, ammonium carbonate also decomposes to form carbon dioxide gas, ammonia, and water, as shown in the equation below. Ammonium carbonate solid arrow CO2 gas plus ammonia gas plus water. To balance the equation, put 2 where there is ammonia. Now the next type of salts we want to look at is nitrates. Now nitrates, the product formed depend on the position of the metal in the reactivity series. Nitrate of potassium and sodium decompose to give you metal nitrites and oxygen gas. Example, you say when potassium nitrate is heated, it gives potassium nitrates and oxygen gas, as shown in the equation below. Potassium nitrate solids, arrow, potassium nitrites solids plus oxygen gas. Balance the equation, place 2 where you have potassium nitrate and 2 where there is potassium nitrate. Now nitrate of calcium, magnesium, aluminium, zinc, iron, lead and copper decompose to give you metal oxides, nitrogen oxide gas and oxygen gas. Now for example, you say A, action of heat on zinc nitrates. The equation will be zinc nitrates, arrow, zinc oxides plus nitrogen oxide gas plus oxygen gas. To balance the equation, place 2 where there is zinc nitrates, 2 where there is zinc oxide, and 4 where there is nitrogen oxide gas. Now observation made during the experiments here is white zinc nitrate changes to yellow when hot and white on cooling. Another observation is brown fumes are formed. Reason for the observation: zinc nitrates decompose on heating to form zinc oxides, which is yellow when hot and white on cooling, brown nitrogen oxide gas and oxygen gas. B, copper nitrate. B is action of heat on copper nitrate. Equation becomes copper nitrate, arrow, copper oxides plus nitrogen oxide gas plus oxygen gas. Balance the equation, place 2 ways copper nitrate, 2 where you have copper oxides, and 4 where there is nitrogen oxide gas. Now observation made during the experiments is green copper nitrates. Green copper nitrate solid changes to black. 2, brown fumes of nitrogen oxide is formed. Now reason for the observation: at the end of experiment here, we can say a black solid is formed as an observation. Now reason is copper nitrate decompose on heating to form copper oxide, which is black, brown nitrogen oxide gas and oxygen gas. And the next one is C, action of heat on lead nitrate. Equation is lead nitrate, arrow, lead oxide plus nitrogen oxide plus oxygen gas. Now balance the equation: 2 where there's sodium nitrate, 2 where there's lead nitrate, 2 where there's lead oxide, 4 where there's nitrogen oxide gas. Now observation made during the experiment is 1, white lead nitrate changes to orange when hot and yellow on cooling. Then brown fumes are formed. At the end of experiment, yellow solid is formed. Now reason for the observation made is white lead nitrate decomposes on heating to form lead 2 oxides, which is orange when hot and yellow on cooling, brown nitrogen oxide gas and oxygen gas. Now ammonium nitrate. Now nitrate of silver and mercury decompose to form metal, nitrogen oxides and oxygen gas. Example, you say action of heat on silver nitrate. Equation B, silver nitrate, arrow, silver plus nitrogen oxide plus oxygen gas. Balance the equation, place 2 where there is silver nitrate, 2 where there is silver, and then 2 where there is nitrogen oxide gas. Now observation made during the experiments is white silver nitrate changes to gray, brown fumes are formed. At the end of experiment is a gray solid is formed. Reason: silver nitrates decompose on heating to form silver, which is gray, brown nitrogen oxide gas, and oxygen gas. The last one is action of heat on ammonium nitrate. Ammonium nitrate decomposes on heating to form nitrogen 1 oxide and water. Ammonium nitrate decomposes on heating to form nitrogen 1 oxide and water. Equation is ammonium nitrate arrow nitrogen 1 oxide plus water liquid. Balance the equation, place 2 where you have water. Now learners, that is the lesson. That is the end of the lesson. The next lesson we are going to look at action of heat on sulfates and look at what happens when salts are exposed to the atmosphere. Thank you.